Oh, I'm glad you're back. I'm glad that first video didn't scare you away. So let's finish this conversation about graphical limits. First of all, it makes sense right here to review or discuss the common reasons why a limit doesn't exist. There's two common reasons. There's other reasons why it may not exist, but these are the only two that you're really going to see. The first one is the value of the function, f of x is the value, approaches a different number from the left and the right. So numerically, say you're taking the limit of something as x approached, whatever, 7. And when you plugged in 6.99, you got 10.3. And when you plugged in 7.01, say you got a value of negative 6.7. Those are obviously different values, so the limit wouldn't exist. Graphically, say we're doing the same thing. I'm taking the limit as x approaches 7. Graphically, you'll see something like this. Maybe this function ends here at 7, and then maybe starts up over here again. It might look like that. That's an example of graphically, as you approach 7, it's different from each side. So the other reason why it wouldn't exist is if you had an asymptote. So that's, if you're doing it numerically, say we're taking the limit as x approaches 9 of some function. And when you plug in 8.99, you get 10,000. That would indicate that there may be an asymptote. I should say probably be an asymptote. But it is possible that a limit could be 10,000. So to ensure yourself numerically that it is an asymptote, if I plugged in 8.9, I got 10,000. I would try something closer like 8.99. Now, if that goes up, say that was 100,000, that indicates now that that graph is increasing without bound. So that's a vertical asymptote. The limit does not exist. And there's no need to plug in 9.01 now because you already know it doesn't exist because of an asymptote. Graphically, it's very obvious. So say this was 9, an asymptote, you could see it. It could be like that. It doesn't have to go up and down. They can both go to positive infinity, both go to negative infinity, or vice versa. So that's it. One huge thing here. Notice that it says nothing about the function itself existing. And we learned that before. So say the function didn't exist at 4, but you got the same thing from the left and the right. Say this was 10. The limit here would be 10. So it doesn't matter if the function exists or not. And to be clear here, so those are important points. And then finally, I have two more examples here. You've seen in the last video that using a graphing calculator to check graphical limits is not the best way. If I had a graphing calculator, I'd just plug in numbers in anyhow. I would do it numerically. But sometimes you won't be able to do that. Sometimes you'll be given a graph like this. And if you're taking an AP exam, this is really important. So now, first of all, what type of graph looks like this? Well, this would be a piecewise function. This would be the first piece. This would be the second piece. This would be the third piece. And then there are other pieces redefining it here and here and here, but we'll talk about that as the year goes on. So we don't really care about what the equation of this graph is because we're just going to look at the graphs. So first of all, question number 1 says, what is f of 1? So that's not even a limit question. That's a algebra trig question, but sometimes that gets confusing, so that's why I'm including it. F of 1 is the value of the function when x equals 1. Here's x equals 1. The value of the function is the y value, which is 0. Oops. So that's that. F of 6. Well, now we have to go to 6, which is right here. And we're looking for the value of the function at 6. Well, the function is defined at 6, just not where it normally would be here. It's defined right here. So at 6, the value of this function is, looks like -2. Notice we're not going to the left or going from the right because that's not a limit question. It's just a straightforward what's the value of the function question. So now the rest of the questions are limits. So make another little circle here. So the limit as x approaches -5. So identify where -5 is, which is right here. Take your pencil or imagine approaching -5 from the left. You never get there, so you have to stop right here. Approach it from the right. Don't get there. You have to stop right before it, right there. Ask yourself if those are the same value. They obviously are. And the value that they agree upon is right here, which is 1, 2, 3. So I'm going to do the next 4. If you're playing along, you may want to pause as I'm doing this. Maybe try to come up with the answers yourself if you didn't yet. But here we go. So the limit as x approaches -2. Here's -2. X equals -2. When we go to the approach -2 from the left, it looks like our value is -1. When we approach -2 from the right, it looks like our value is -3. So those values are obviously different. So that's a D and E. Now we're going to approach 1. So as you approach x equals 1 from the left, we're stopping here. As you approach 1 from the right, we're stopping here. They match at 0. So that's the limit. Now, remember the first thing we did was what is f of 1? It turned out to be 0. Turns out to be the same as the limit. That's not always the case. We'll see. So now for question number 6, the limit as x approaches 3. 3, x equals 3 is right here. That's a vertical asymptote. Stop there. A limit does not exist at the vertical asymptote. It goes to, in this case, positive infinity from the left. You're done. That's enough. But negative infinity from the right. And finally, number 7 is an important one because it's going to show us here the relationship between the limit and the actual value. So if you look at, we already did f of 6 was -2. Now we're going to look at what's the limit as x approaches 6. Well, when you approach 6 from the left, where's my dot? Here we go. Approaching x equals 6 from the left, we're getting very, very close to 6. We're not getting there. Therefore, we cannot jump to this point here because the limits never get to that 6. So as far as the limit is concerned, the value close to 6 is right here. On the other side, from the right, We're approaching 6, approaching 6, approaching 6. Don't get there, so stop right before it. See if they match. And they do. They match at -3. Even though the actual value at 6 is -2, the limit as x approaches 6 is -3. So that's that one. Now, keep in mind here, if this point wasn't even there, say this point was gone, and I can do that. I can just put white over it. No, I can't. Say that point was gone. I can't do it. 10. Now, if you think about going back to these questions, the answer to number 2 would be undefined. The function is not defined at 6. There's no point. The answer to number 7 would still be -3. So think about that. If you need to, pause the video and think about it before we go on to the last graph, and then I promise I will shut up. Last graph. Now, what I'm going to do here is, again, I'm going to arrive at these answers very quickly this time. You may want to pause this, think about what the answer should be, and see if you agree. So, the limit as x approaches 0 of this function, on the left and the right, they will both equal -2. The limit as x approaches 3. Here's 3. From the left and the right, you will get to, they will match at 1. That point up there has nothing to do with it, so this would be +1. The limit as x approaches 5, you should see from the left, you're at -2. From the right, you're at -1. They do not match. This does not exist. The limit as x approaches 9. That's right here. They do match from the left and the right, and they match at -1. So those are the 4 limits. The actual values, that's what 6, 7, 8, and 9 are about. F of 1, right here. It looks like it's at -1. It might be a little below, but we'll eyeball and say -1. F of 3, that's right here. The value of this function at 3 is defined right here, and that equals 3. So you see the difference between limits and actual values. At 5, you see this closed point here. That's where the function is defined. So f of 5 equals -1. And finally, f of 9. There's an open circle, and there's no other point here to define it. So there's no definition of the function at 9. So you can say undefined. Some people will say DNE doesn't exist. That's okay. Undefined is better when you're talking about the value of a function. There's no defined value. So that is it. We're going to skip this. Do what we need to do to look over these videos again. When we come back to the synchronous learning, which is the second half of class, if you have questions, you may ask. I'm going to give you some more worksheets to work on. If everybody's good, we can move on a little bit. But that's that. I'll see you in a bit.